Okay, we're almost in the home stretch here. The next uh, two scripts we're going to look at are actual encoders and decoders, which are going to take basically the encryptions that we did in the encryptors, decrypt and encrypt, and just wrap them around some of our specification. We'll start with the encryption part of stuff. I'm going to introduce this concept I call a goober. A goober is like a fob. I'm going to use it as a security object to check that basically in this case it's going to be if my username is in this goober, encrypted goober, then I can run something, and I'll show you this here in the next function down. The goober is not supposed to be secure. It's the security's in the encryption. I don't want anybody to put like my username or whatever you're going to use this. So I'm actually putting the key in the decryptor key in the goober when it runs, so you can decrypt it and do, hey, is XYZ allowed to do this? If yes, then go. So that it's going to be a file on the system that can't be modified by anybody. So you protect the encryptor part of that part and hand that out. We'll just not walk through. We'll walk through it in the end examples. But anyway, we're just going through. We're going to get the goober. We send it what we want to encrypt. We get a key on the fly in this case. It doesn't have to be a huge key. We just want to not have the end user or whoever's on there be able to change that goober on the fly. The key itself is the goober itself will have the data to encrypt. And we'll walk through what's going on there. It could be anything. I'm going to have a list of users in my example, but it could be really anything. Author, just who my login is, where it came from, create date, and then some padding junk to make each goober look a little different, even if it looks the same, using the same key for whatever reason. It goes and encrypts that dictionary right there, and then it pads I don't want to say pads these though, pad up here. It takes the encrypted payload, and along with it gives you the way to how to decrypt that. I call it data, and this is the part to decrypt. What we're going to want to do is encode a file, so we can have a file on the file system that's like maybe usernames or passwords or connection strings or something you just want to hide. We'll go through a couple of objects in the example stuff, but it's basically going to be the same thing. I'm going to give it an object I'm going to encrypt. Let's say it's a username and password or a dictionary or whatever, and a file I'm going to send it off to. And it's just going to split off the file name, file path. I'm going to check if it exists. I'm going to tell you if the file path doesn't exist, and it'll error out. If the file exists, I'm going to say the file already exists. I'm not going to do any overwriting. I'm not going to destroy things that go out there. From the last key mate functions, I'm going to get a random key from the public key store. As you remember, if I look over here at my random thing, I'm pulling it from the public DB, and I think up here I do. Nope, I don't. Sorry, it's just going to take whatever it's defaulted to the public key sec store, and then it's going to encrypt just like it did on the goober. It's going to give me my data, my object, author, all this stuff here, and then my padding. I'm going to encrypt it, and then I'm going to dump the file, which is going to do a pickle dump to the file system. Along with this, I get a set of run goober questions, and we'll go through this one in an example in the next video. But basically, how to create a goober? Well, it's going to ask you for the path. It's going to ask you what the goober name is going to be and what you want to put in it, comma, delimited, and then it's going to run the goober. So with the encoders there, you can encode things, right? You can basically do whatever you want. I'm just encoding an object to a file at this point, and what's my object in this case depends on the calling function. It could be a dictionary, it could be a list, a string, or whatever you want it to be. Is fine, really. I mean, we're gonna put some padding in here, right there. We're gonna get you. It's not signing, but it tells you where it came from. We can talk about signing in a later video. I'm not too concerned about it now because this for us right now is a closed system. The decoders are pretty much the opposite. Here I'm importing MasterDB because I need to be able to get to MasterDB to decode it. And you have the decode goober, which is literally the reverse of what's going on in the from the other file. I'm loading the file. I'm getting the data out. I'm seeing if it's okay. I put this sorry, I'm going through this really fast, but it's pretty, I think, self-explanatory. There's a user auth test that I'm doing. I'm giving it the goober file, which is the encrypted file. I am getting the data off of that file. I'm decoding it, and then I'm going to right now just say, hey, is it my login? If it's in that login, it says good, your go. If it's not, it's going to say not authorized, and unauthorized means there's something wrong with the goober. You don't have to do it this way. Obviously, I'm doing it this way because it's easy for me. You could do an ACL-like thing. Well, I only accept a goober from this person on this on this workstation or whatnot. Anything's possible. You probably should sign it, but you don't have to. And then the file decode is exactly like the file encode object to file. Takes a file name, the goober name, and then the key store master. We need master because we need that D. We raise this to the dth value, and it just does, loads the file, and that's a unpickling, and it just reads the key from the key store because the ID is in the in the thing we encrypted. I think it is. Should be. My key encrypted. Yeah, right there. Sorry, I wasn't looking. So we know where to look for. Of course, you're going to want to be able to tell it which database or which file system to pick from. Right now there's only one, so it's not that complex. Anyway, it's just a reverse operation. Now, of course, we're talking about encoding and decoding stuff. If it's Python, I could stop this and break it. So break, point it, and change things on the fly. So when we do this, we're going to want to make this a little harder for the average person to get into. And by the average person, I mean me. So what I'm going to do is I'm going to go to my E directory and go to my root. Right, where am I going? Scripts maybe. Python, encryptions. And say, I have this. Oh, look. So I'm going to say, I'm going to use Nutka right there, and I'm going to create a PYD file, and I'm going to make the encryptors, encode goober, encoders. We want to call it, what do we call this up here? Encoders. We're going to make a DLL for encoders. Here it goes. It's compiling. Take a little second to do that. 0%. Awesome. We could talk about, and this is Python, so it's not the fastest. We can speed things up. Maybe run a Python, mark this up for C code, but this is easier this way. And let's just go with it for right now. And decoders py, and we're compiling that. Go. And done. So what that did, it should have created these two PyD. Remember that these are version specific, so it'll only run with 3.9. So if you have other versions, just run this for the different version, and you can get rid of the names of I think this is CPython 3.9, but I keep it there. I have this utilities directory that I keep my DLLs in the replace the file destinations, please, in the Python path so it can find this stuff out. And that's pretty much this video. The next video we're going to go and work with both of these things and see how they work.